So we want to find concavity, points of inflection, and this all relates to the second derivative. So if I have f of x equals x to the fourth minus 4x cubed, I got to go to the second derivative. The first derivative will tell me max, mins, increasing and decreasing. The second derivative will tell me about the concavity and points of inflection. A point of inflection is where the graph will change concavity. So we set it equal to 0, factor, and I'm left with x minus 2. So x equal to 0 and x equal to 2 are my possible points of inflection. Possible. So I plug in 0 and I plug in 2, and then what we do is just like we did with the first derivative test, we pick some test values. Okay, and when I plug in -1, we plug into the second derivative, and when I plug it into, it's easiest to plug it in here and compare signs. 12 times -1 is a negative, times -1 minus 2 is a negative. So we get a positive, and I showed on a graph showing that it curves up for concavity. F double prime of 1, when plugged into 12x, it's a positive. When plugged in x minus 2 is a negative, so we get a negative number, sorry for the mistake, and it curves down. F double prime of 3, that's going to be a positive times a positive, which is positive, so it curves up. So we have points of inflection at 0, 0. I get this from the original function. And we get a point of inflection at 2, when I plug in 2, I get 16 minus 4 times 8, which is -16. So these are the points of inflection where the concavity changes. So I can go concave up, interval -infinity to 0, union 2 to infinity, and then concave down 0 to 2.